Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will continue talking about complex numbers, and specifically we will deal with trigonometry. First, I'd like to remind you by the signs of trigonometric lines. Remember, we have four trigonometric lines, which are sine, cosine, tangent, and cotangent. Alpha is an oriented arc in an oriented circle, and the table below shows the signs of the trigonometric lines. So we have sine alpha, cosine alpha, tangent alpha, and cotangent alpha. And we have four quadrants, which are the first, the second, the third, and the fourth quadrants. In the first quadrant, all trigonometric lines will be positive. In the second quadrant, the sign will be positive only, and other trigonometric lines would be negative. In the third quadrant, the tangent and cotangent would be positive, and sine and cosine would be negative. And in the fourth quadrant, the cosine would be positive, and other trigonometric lines would be negative. That's why we use the abbreviations A, S, T, C. So A, all are positive. S, sine is positive only. C, cosine is positive only. And T, tangent and cotangent are positive. This is the cosine axis, and this is the sine axis. Now, if we take an angle between 0 and pi over 2, let's say it's somewhere here, we can see if we project on the sine axis that the sine is positive, and if we also project on the cosine axis, the cosine is also positive. And we all know that tangent is sine over cosine, so positive over positive is positive, and the cotangent is cosine over sine, so also positive over positive is positive. Now, if we choose an angle between pi over 2 and pi in the second quadrant, which is somewhere here, and if we project on the sine axis, we can see that the sine is positive. Whereas if we project it on the cosine axis, on the x-axis, we can see that the cosine is negative. So tangent is positive over negative, which is negative, and cotangent is negative over positive, which is negative. Now in the third quadrant, if we choose an angle somewhere here and we project on the y-axis, on the sine axis, we can see that the result is negative. And if we also project on the cosine axis, which is somewhere here, the result would be also negative, and negative over negative is positive, and this is also positive. And finally, if we come here on the fourth quadrant, alpha is between 3 pi over 2 and 2 pi, somewhere here. And if we project on the y-axis, on the sine axis, we see that the result is negative. And projecting on the x-axis or on the cosine axis leads to a positive quantity. Now, instead of memorizing this table, we can just memorize the abbreviations A, S, T, C. As I said before, A means all, S means the sine is positive, C means the cosine is positive, and T means tangent and cotangent are positive. Now this is alpha. Let's see that. Now this is alpha, and let's see the relation between minus alpha and alpha. This would be minus alpha. If alpha is between 0 and pi over 2, minus alpha would be between 3 pi over 2 and 0. Now, sine of minus alpha is minus sine alpha, because here in the fourth quadrant the sign is positive, so we put a minus sign here. Whereas cosine of minus alpha is cosine alpha, because in the fourth quadrant the cosine is positive. Tangent of minus alpha is minus tangent alpha, and cotangent of minus alpha is minus cotangent alpha. So let me re-explain it. Sine minus alpha is sine alpha, cosine minus alpha is cosine alpha, so we leave the trigonometric line as it is. But how do we choose these signs? We just go back to the trigonometric circle, and minus alpha is an angle which is in the fourth quadrant. In the fourth quadrant, the cosine is positive, so we leave the cosine as it is, and others are negative. Let's see the same idea for another quadrant. Now, if we want to talk about pi minus alpha, this is pi minus alpha, which is in the second quadrant. Now, in the second quadrant, the sign is positive and others are negative. So the sign is left as it is, whereas cosine becomes minus cosine. Tan of pi minus alpha is minus tan alpha, and cotan of pi minus alpha is minus cotan alpha. So we just leave the sign as it is, and we multiply other trigonometric lines by a negative sign. Now let's see also the same idea for pi plus alpha. This is pi, and if we add alpha, we would be somewhere here. In this case, the tangent is positive, sine and cosine are negative. So as you expect, sine of pi plus alpha is minus sine alpha. The cosine is also minus cosine. Tan is as it is, and the cotan would be the same as tan. Now, let's see the case of pi over 2 minus alpha, and this is pi over 2, which is 90 minus a certain quantity between 0 and 90 becomes here in the first quadrant, and in the first quadrant all are positive, but we have something else here. So the sine is positive, the cosine is positive, the tan is positive, and the cotan is positive. But here, in case we have this pi over 2, the sine becomes a cosine and the cosine becomes a sine. So we flip the trigonometric lines, and similarly for tan and cotan, that become cotan and tan. Now the last case, pi over 2 plus alpha, it's somewhere here. This is pi over 2 plus alpha. In this case, the sine gives a positive quantity, whereas the cosine is negative, the tan is negative, and the cotan is negative. But pay attention, dear students, because we have over 2, this over 2, we have to flip the trigonometric lines. Sine becomes cosine, and cosine becomes sine. So how can we deal with such formulas? We just go back to the trigonometric circle, but pay attention, in case we have over 2, we have to flip the trigonometric lines. Now let's see some examples. Simplify. Cosine of pi minus alpha. We go back to pi minus alpha. It's somewhere here. The cosine in this case is negative, so this becomes minus cosine alpha. Now this quantity, we simplify each term alone. Cosine of pi plus alpha. Pi plus alpha is somewhere here. The cosine is negative, so this becomes minus cosine alpha. And sine pi over 2 minus alpha. This is pi over 2 minus alpha. It's in the first quadrant. The sign in this case is positive, but pay attention to flip from sine onto cosine. This would be 3 cosine alpha, and the final answer is cosine alpha. In this case, we have minus alpha. Fourth quadrant, we have pi over 2 plus alpha. The second quadrant, and minus pi over 2 plus alpha. This is minus pi over 2 clockwise, and then plus alpha anti-clockwise. So this would be in the fourth quadrant. Now for the first one, in the fourth quadrant, the sign is negative. This is minus sine alpha. In the second case, the sign in the second quadrant is positive, so it's left as it is, but we flip the trigonometric lines. And here in the fourth quadrant, as I said before, the cosine is positive, so we leave it as a plus, but we flip the trigonometric lines. And this becomes minus 3 sine alpha plus 3 cosine alpha. Now the fourth case, we have the fourth quadrant for minus alpha, we have the third quadrant for pi plus alpha, and we have minus pi over 2 minus alpha. This is minus pi over 2, and minus alpha means we go clockwisely, so this also falls in the third quadrant. Now in the fourth quadrant, the cosine is a cosine. In the third quadrant, the cosine is minus cosine and the sine is minus sine, and we flip because we have over 2. And this becomes 4 cosine alpha. Now let's see the application. Simplify this one, try to do it alone. Now pi plus alpha is in the third quadrant and the sign in this case is negative. The second part, try also to do it alone. While 3 pi over 2 minus alpha, this is a 3 pi over 2 minus alpha, we go clockwise, so this would be in the third quadrant, and 3 pi over 2 plus alpha would be in the fourth quadrant. Remember, in the third quadrant, the cosine is negative, so this is a minus, and try to flip the trigonometric lines because we have over 2. And in the fourth quadrant, the sign is negative. We also flip the trigonometric lines, and this would be the final result. Try to do it alone. Well, here, remember, 100 pi is the same as 50 complete rotations. So as if it doesn't exist, we can eliminate it. We get sine of minus alpha. And here, this is not the case of over 2 because 18 pi over 2 is 9 pi. So we have to simplify first. And then again, 9 pi is the same as pi. Because if we eliminate an even number of pi's, what remains is only 1 pi. Now, minus alpha is in the fourth quadrant. This becomes minus sine alpha. And pi plus alpha is in the third quadrant. This is also negative, and this would be the final answer. Now, the last one. Try also to do it alone. Well, 5 pi over 2 is the same as pi over 2, because if we eliminate 2 pi, we get pi over 2. Remember, 5 pi over 2 is 2.5 pi, which is the same as 0.5 pi. And because we have over 2, the cosine becomes a sine. And minus 5 pi over 2 is the same as minus pi over 2 minus alpha. This is minus pi over 2 minus alpha. We are by now in the third quadrant. The cosine is negative, and we flip because we have over 2. And the final answer would be 3 sine alpha. Now let's continue and see this example. We need to write each expression in the form of r brackets cosine theta plus I sine theta, where r is a strictly positive real number, so r is strictly positive, and theta is a given angle. Now here I'm trying to clarify the question. We need to write the expression having an r outside the brackets where r is strictly positive, and we should have the same angle theta here and there, and we should have a plus in between. Now this is the trigonometric circle because we need to use it. This is the first part. So how do we write it in this form? We can just take 2 here in common. We get 2 cosine alpha plus I sine alpha. So r in this case is 2, and theta in this case is alpha. Now in this case, if we take 5 as a common factor, we get r, but we have a problem with this minus. What do we have to do? We need to change the sign of sine alpha. This is alpha. Now, where do we have on this trigonometric circle a positive cosine and a negative sine? This would be in the fourth quadrant, which is called minus alpha. So we change the sign of sine alpha by using the fourth quadrant. This would be 5 into cosine alpha minus I sine alpha. And to remove this minus, we change this alpha into minus alpha. And remember, cosine of minus alpha is cosine alpha, whereas sine of minus alpha is minus sine alpha. So these two expressions would be equal to one another, and this would be the final answer. And in this case, remember, r would be 5, and theta would be minus alpha. So what do? We try to find a quadrant where the cosine is positive and the sine is negative, and this would be in the fourth quadrant, and this is represented by minus alpha, so we change the angle alpha into minus alpha. Let's apply more. What do we do in such a case? We need the cosine to be negative and the sine to be negative, and this happens in the third quadrant. Both of them are negative, and this is called pi plus alpha. So we change the signs of cosine and sine by using the third quadrant. Now if we take 4 in common, we get minus cosine alpha minus I sine alpha, and if we change alpha into pi plus alpha, we get cosine of pi plus alpha, which is minus cosine alpha, and sine of pi plus alpha, which is minus sine alpha. So this is the required part, and in this case r is 5 and theta is pi plus alpha. One more application, this case, pay attention here. Here we have a sine here which should be translated into cosine, and a cosine which should be translated into a sine. So here we try to use pi over 2 minus alpha. Always use pi over 2 minus alpha. Now, so we change the sine into a cosine and the cosine into a sine by using pi over 2 minus alpha. So if we take 10 in common, we get sine alpha plus I cosine alpha. This is not similar to what we need, because what we need is that the trigonometric line besides I should be a sine, and we have a cosine. So we use pi over 2 minus alpha. And finally, r is going to be equal to 10, and theta will be equal to pi over 2 minus alpha. Now this is the trigonometric circle with all the required details. And I want you to write each expression in this form as we did before. Now this expression, try to do it alone. Now if we take 3 in common, we get minus cosine alpha plus I sine alpha. We need the cosine to be negative and the sine to be positive, and this falls in the second quadrant, which is pi minus alpha. So we replace each alpha by pi minus alpha. Now this case, try also to do it alone. If we take 5 in common and we translate the sine into a cosine and the cosine into a sine by using pi over 2 minus alpha, so that the expression is written in this form, we get this answer. Now we need the cosine to be negative and the sine to be negative, and this is in the third quadrant. So we have to add a pi to the angle that exists. This is the angle. If we add a pi, we get this expression with 2 pluses before the sine and the cosine, and this would be 3 pi over 2 minus alpha, and we get the final answer. Now what happens in such a case? Try also to do it alone. If we take 2 in common and we translate the sine into a cosine and the cosine into a sine, we get this expression. We need the cosine to be positive and the sine to be negative. So this is the fourth quadrant. We just multiply the angle that we have by a minus, and this is what we get. Now the last expression, try also to do it alone. If we take 9 in common and we translate, we have the cosine is negative, the sine is positive. This is in the second quadrant. So we have to write pi minus the angle that we have, and this becomes pi minus pi over 2 plus alpha. Remember, we multiply all of this angle by a negative sign. Similarly here, and this would be the answer. Now Rami or Amir, we need to write this expression in this form. Let's see what they did. Rami wrote sine alpha minus I cosine alpha, and then he used the trigonometric circle after he noticed that the sine is positive and the cosine is negative. So he went on to the second quadrant. and then he translated the sine into a cosine and the cosine into a sine by using pi over 2 minus theta, and this is theta, and this was his final answer. Now, what did Amir do? He translated the sine into a cosine and the cosine into a sine first, and then he noticed that the cosine is positive and the sine is negative, and this is in the fourth quadrant, and this was his answer. Now, which answer is correct? I think both answers are correct in this case. Which method is more preferable? I prefer Amir's method. Try first to translate the sine into a cosine and the cosine into a sine, and then manage the negative and positive signs. Thank you.